All right, hello everybody. Today I just want to walk you through a basic overview of homework number 8. After having completed homework number 7, this one should seem considerably less elaborate, I guess I would say. But just to make sure we're on the same page with everything you have to do for it, I'm going to just show you the basics of what you have to do. So there are 3 parts to it. This one's about correlation and linear regression, which has been the topic of the past 3 lectures or so. I actually still have to record the 3rd lecture, but that's okay because you won't know any difference in this asynchronous environment in which we're working. But what we want to do for the first part of this homework exercise is go back to this monomorphemic and monosyllabic words database. So I'll just load that up here into my R console so we can take a look at it again. And maybe I'll... Do you like the way I say all? Maybe I'll make the font a little bit bigger here. But yeah, so we have this monomorphemic, monosyllabic words database. We have all these variables we've seen before. What I want you to do for this first part is fairly straightforward, just to make sure you know how to do it. Number 1, calculate the covariance between any 3 pairs of variables. So pick any 3 of these that you like, as long as this computation makes sense. Calculate the covariance between them. Part B, calculate the correlation coefficient between any 3 pairs of variables. That doesn't have to be the same 3 pairs of variables as you did for A, but it could be if you want it to be that way. And then for part C, calculate the coefficient of determination between any 2 variables. And for that coefficient of determination, state whether or not it is significantly different from 0 and report the results of the statistical test you use to test that hypothesis. So these are pretty mechanical here. This is also mechanical to start with, and then you have to do a little bit of thinking after it. But hopefully not too much. So that's part 1. You work with that database. For part 2, you do something a little bit different. We take a look at some people's grades from when I taught Ling 201 in the fall of 2012. So I'll just show you the summary of this grades database. Actually, I'll show you the whole thing. So basically what this has is there were 87 students in this class, and if you've taken my 201, and I know a few of my 201 students have gone on to become grad students eventually, I made this database or data frame a little bit different. I might load it in again. So I'll go back to this. This is, I think I mentioned this before. This one has sort of a unique identifier at the beginning in the first column for each row. So you can call that row.names equals 1 in the command of when you load it into a data frame in R. And that will simplify things a little bit because basically there's just 2 variables that we care about here. So for each student, they have a final grade, which is a percentage mark from 0 to 100%. So this person got 80.1%. It's labeled as from 0 to 1 because that's the same thing as 0 to 100%. And then if you take my 201, you know that I do these exercises called quick writes at the beginning of each class. It's changed since the pandemic hit. I've moved it online, but in the old days, at the start of each class, you do a little bit exercise based on the topic of whatever we were going to talk about that day in class, and then you'd hand it in at the end of the class, and you get credit for being there that day, basically, and also some intellectual exercise for doing something linguistics related to start the class off with. Anyways, there are 25 total classes in a semester of 201, the way I teach it. So the max of those is 25, but basically gives me a way to take attendance in some fashion. So the kind of funny thing I like to think about is how much does it matter if people actually come to class? So some people, you may notice, come to class more often. Some people come to class less often. Some people hardly come to class at all, so on and so forth. How much does that affect their final grade? So based on these numbers, I want you to answer 2 questions. Maybe I'll make this bigger too so you can see it. On average, how much did attending the lecture improve each student's grade in percentage points? And then question B, on average, what would a student's grade have been in percentage points had they not attended any lectures at all? So how much innate knowledge of linguistics is out there in people's minds even before they take my Ling 201 class? Because you might have some. or at least enough to do some of the exercises and tests in the class itself. So answer those 2 questions based on those numbers right there. And then there's also a deep thought question, which is kind of for fun, but I still want you to answer it seriously, which is, do you think that attending one class would really raise a student's overall grade by the number of percentage points you calculated for part A of this question? Why or why not? Yeah, so it's a little bit philosophical there, more than statistical, but still, give me your best answer for that one. And let me know what you think about all this. Right. So, we'll find out what the moral of that story is, but it's probably going to be come to class. So I'm glad you're watching this. I'm glad you're paying attention. Let's take a look at the last set of problems or questions I want you to answer. And for this, we're going to go back to this performance data frame here that I put together basically, or we put together kind of collaboratively for this class. And I gave you normalized performance in this particular version of it. So yeah, it's this one with all the different speakers and producing different vowels and measuring the VOT. That's what you guys did. That's your contribution to it. You also may have told me what your height it was, and so on and so forth. And I measured the F0, F1, and F2 for the different vowels that you're producing these stops with. Hopefully this all looks a little bit familiar. What I want to do with it now is I want you to calculate the value of the correlation coefficient between 2 variables, one of which we haven't played around with yet, which is your height, and the other is whichever one of the variables I've got listed here. So for part 1 here, or part I, give me the correlation coefficient between height and F0. For part 2, give me the correlation coefficient between height and F1. For 3, between height and F2, between 4, height and VOT. So it's always height in one of these 4 variables. Just tell me what the value of the correlation coefficient is here, which we've been calling R. It's a magic number, remember? Okay, that's part A. That's pretty simple. Part B gets a little more involved, so I'll walk you through this in the lecture notes, but remember, use Fisher's R to Z transformation to test whether each of those 4 values of R are significantly different from each other, and report the results of each significance test you run. So just to be clear, first of all, before I get into this just to be clear part, I'll give you another just to be clear part. What I want you to test is, say, the number you get from part I here versus the number you get from part II. So this is going to be the R value between height and F0. I want you to look at whether that R value is significantly different from the R value you get for this calculation between height and F1. So comparing the correlation between height and F0 to the correlation between height and F1. Is that different significantly? That's one comparison you're making, but just to be clear, you're ultimately going to be making 6 different comparisons for the question, right? So you can compare F0 to all 3 of the ones below it, that's 3, and then you can compare F1 to these 2, that's 2 more, and then you can compare that to that, that's 6 total, right? So use Fisher's R to Z transformation to see if those values of R are significantly different from each other and report the results of the tests that you run. Okay, that's part B. Part C, of these 5 variables in the data set, determine which one, has the most normal distribution, and also tell me which one has the least normal distribution. And you can use whatever test you think is appropriate for that purpose. I'm not going to be picky as long as it's appropriate and makes sense. And then once you've figured out the answer to that question, make a quantile plot of each of these 2 variables distributions, along with the appropriate best fit line on each graph. So at the end, you start out with these 5. You look at their distributions, you figure out which one has the most normal distribution, and then you figure out which one has the least normal distribution. For those 2 variables, make a quantile plot, and then also plot the best fit line on those graphs. We've talked about this stuff before, so hopefully it all makes sense. And if you don't remember what I'm talking about, go back to the lecture notes or the videos, and hopefully it'll make more sense after you reviewed all that. Send me your R consoles and the write-ups of your answers via the Dropbox on D2L. Please let me know if you have any questions. I'm making this video on Tuesday, November 2nd. This is due after the break on Friday, November 19th at 5 p.m. If you want to get started on it earlier, it's probably not going to take you 17 days to finish. Probably take you, more than 17 minutes probably, but it's not going to be as hard as homework number 7. So breathe easily, but still maybe get working, because that'll make it even easier for you. All right, and let me know if you have any questions about anything. Hopefully this clears up most of the issues, but if there's anything remaining that doesn't make sense, let me know as soon as you can, and I will try to answer as soon as I can as well. All right, see you next time.